Right. Forces are defined as just a push or a pull on an object. They're going to have direction to them, these forces. So the push or pull on the object is going to be in a direction, which makes forces vector quantities. In science, we use the Newton as our unit. It's abbreviated capital N. 1 Newton is exactly the amount of force that will cause a 1 kilogram object to accelerate 1 meter per second squared. That's how a Newton is defined. 1 Newton is the amount of force you have to apply to get 1 kilogram, a 1 kilogram object, to accelerate by 1 meter per second. It is approximately, 1 pound rather, is approximately 4.448 newtons. So it's just a little less than 4.5 newtons to a pound. The effects of a force, sometimes you'll experience a force and there will be no effect. Sometimes it will cause a change in direction. Whoops. Sometimes it can cause a change in velocity or speed. To determine what the effects of the force is going to be, you need to look at the net force. You need to take into consideration all of the forces at play on that object. The net force is the combination of all forces on an object. Okay, we can have balanced forces or they can be unbalanced. If they're balanced, then they will look like this, where we've got 5 newtons of force pushing this box to the right, and we've got 5 newtons of force pushing this box to the left. So these forces are equal in magnitude but opposite in direction. That makes the net force, when we add these up, positive 5 newtons to the right plus negative 5 newtons to the left gives us a net force of 0 newtons. And the effect will be negligible. There'll be no acceleration of this object. It won't move, it won't change directions, it won't speed up or slow down based on these forces. If the forces are unbalanced, however, then the effect will be different. For example, here we've got 10 newtons of force to the right and 5 newtons of force to the left. These forces are unequal in magnitude because 10 is not equal to 5, and they are still opposite in direction. So our net force now, we've got positive 10 newtons to the right and negative 5 newtons to the left. So our net force is a positive 5 newtons, or 5 newtons to the right. So the effect on this object is that it will accelerate to the right. The acceleration will be in the direction of the greater force. So whenever you have unbalanced forces, it will cause an acceleration, and that acceleration will be in the direction of the greater force. Okay, now remember when I say acceleration, I can mean to speed up, to slow down, or to change directions. So if this object were sitting still, then it's going to accelerate, it's going to speed up and move to the right. If this object is already traveling very quickly to the left, then it might just slow down because the acceleration would be in the opposite direction of its velocity. Similarly, this object up here that has that balance forces acting on it, that doesn't mean that it isn't moving. It could very well be moving, and that its movement is not being changed by the forces. There is no acceleration. That doesn't mean that there's no velocity. Remember that an object can have velocity without having acceleration. Okay, let's look at some examples. If a ball is thrown to a batter who hits it back towards the pitcher, is the force applied by the batter balanced or unbalanced? This force would be unbalanced. Now, how can we tell that it's unbalanced? Our evidence for saying it's unbalanced is that there was acceleration. The ball changed directions. If there had not been an unbalanced force on it, then that ball would have continued to travel at the same speed in the same direction forever, right, once it left the pitcher's hand. Let's look at this. A boy sees a soccer ball sitting on the soccer field. Are the forces balanced or unbalanced? Well, it's just sitting, so I'm going to assume that it's balanced because there's no evidence that there's any acceleration. There's no change in direction, it's just sitting still. There's no change in velocity. Or speed, because it's still just sitting still, it's at rest. Does that mean that there are no forces acting on it? No, it does not. If the ball is sitting on the grass, gravity is still pushing down on it. The earth is still pushing up on it. But what it tells us is that those forces are balanced. There may be wind blowing on it, pushing it one way, but there's friction pushing the other way. Okay, it doesn't mean that there are no forces. It simply means that those forces are balanced. A boy kicks the soccer ball and it rolls east. Here are the forces balanced or unbalanced. Here, they're unbalanced. And how do we know? Because there is acceleration. There's a change in velocity. It changes speed. Rolling from rest tells us that it's changing speed, and it went a direction when before it had no direction because it was at rest. Right? So there's acceleration because there was a change in velocity. The soccer ball then slows down and comes to a stop. Again, these forces are unbalanced. And how do I know? Because again, I see that there's acceleration. The speed changed. It went from rolling to rest. So it went from having a speed greater than 0 to having a speed of 0, which tells me that it accelerated, which means that those forces must have been unbalanced. At this point in your notes, you should know what a force is, you should know the unit, the SI unit for force, and what it means. You should know what net forces are and how to calculate them. Oops, sorry. You should be able to describe the effect of balanced and unbalanced forces on an object. In order to do that, that means you need to know the definition of balanced and unbalanced. Make sure you have this information in your notes.